Welcome back, chemistry fans. Today, what we are going to get to do is make the solutions to that gas law exam. So if you don't mind, let's jump right into it. All right, let me share my screen and we'll get started here. Okay, here we go. So the first question, it is asking us, it's got liters, so that tells us it's a volume. So we've got something here with a volume, we've got a temperature, and then we've got another volume. So what that tells me is I've got volume over temperature. Volume over temperature. We got it for ones, we have it for twos. Here is probably where you messed up, one of two different locations. Either A, you forgot to add 273 to 15.6. Should be 288.6. The volume be 0.625, or what you forgot to do is to add, it says that it's an additional 1.23. So we would have 0.625 plus 1.23 to get 1.855. So now what we're doing is just cross multiplying, solving for the t. And so we would have 1.855 divided by 0.625 times 288.6, and you would get 856.6 Kelvin. If you subtract 273 from that, you would get 583.6 degrees Celsius. Either of those would be correct. All right, moving on to number 2. Density. Density is mass over volume. So we're given moles. We are not given grams. So this is mass, not moles. So I've got to take the 2.53 and multiply it by the weight of 2 chlorine. So 2.53 times 71 gives me 179.63 grams. There's my mass. Now it's at STP. That means we're going to do 22.4 as our volume. So 179.63 divided by 22.4 gives us 8.02 grams per liter. Moving on. Number 3. In this one, we are given, let me move my talking head out of the way. We've got 2 temperatures. So that automatically tells us that we're not dealing with the ideal gas law. So we've got 2 different sets of temperatures. Temperatures always go on bottom, must add 273 to both of these values. We've got a volume and we have a pressure. What is the final? But it's doubled. So that's the key here with the volume, is that it's doubled to 9. So that means it was at 4.5. We have an initial pressure of 1550. So we're looking for the final pressure. Our temperatures, 273 minus 38.3 is 243.7, and 18.5 plus 273 is 291.5. Okay, 234. I've got that transposed here. Sorry. 234.7. Okay, now we can cross multiply, solve for the P. So I've got 4.5 times 1550 times 291.5 divided by 234.7 divided by 9 gives me pressure of 962.6 torr. Multiple units that you could have put it in. I had it in multiple different units. Divide that by 760, turn into atmospheres, then multiply it by 8.314. So either way you go about it, you can get different answers. Start there, and then we can work to see if I screwed up and didn't give you full credit. Should have had all the answers on the version of the exam. Okay, here's what we've got. Now, finally, we've got a PV equals nRT, but it's not as simple as you would think, because we've got 3 different gases going for it. So all of them, though, are summative. So I take the 159.5 and I divide it by the weight of sulfur dioxide, which is 64, if I add up all those weights, and I would get 2.49 moles for the sulfur dioxide. 57.8, I divide it by the weight of chlorine gas, which is 71, adding those off the periodic table, and I get 0.814 moles. So I've got two of my mole values, and then I take 244 and I divide it by the weight of argon, which is 40. Oh, it's down here at the bottom. Yeah. Argon, which weighs 40. And you get 6.1 moles. So I've got my 3 mole values. I got to add them together. 6.1 plus 0.814 plus 2.49. And I get a total sum of moles. So PV equals nRT. My moles is 9.404, whatever. Pressure in kilopascals, 8.314 should have been your R value. Your T is 11.6 plus 273. And that is 284.6. Your pressure is what we're looking for. Your volume, it says, is 500 liters. So 500, we don't know the pressure. So 9.404 times 8.314 times 284.6 divided by 500 gives you pressure. Sorry, we're looking for pressure. Gives you 44.5, and that'd be kPa. All right, let's move on to 5. Mixture has 154 of each of these gases, has a total pressure of what is the partial pressure? Okay, so we have to figure out what their mole ratio is. So this is Avogadro's law. So I've got 154 of ammonia. So 154 divided by 16 tells me the number of moles. 154 divided by 16. It's not mass. It's about the number of particles. And then I take the 154 and I divide it by the weight of ammonia. 17 is its weight off the periodic table. By the way, this weight's here 16, this weight here is 17. And so I would have 154 divided by 17, and that's 9.06. And then I would take the 154 and divide it by the weight of helium, which is 4. And that is 38.5 moles. So I have my 3 mole values. I got to add all 3 of them together. And I get a sum of 57. So the sum of all the moles is 57.185. Okay, with that said, now what we've got to do is do a mole ratio. So I'm going to take 9.06 for the ammonia divided by 57.185. So this is ammonia. It's actually asking only for the partial pressure of the helium, so we won't do that. So we will take 38.5 over 57. 38.5 divided by, answer is 67.33% helium by the mole ratio. So then we take that percentage and we multiply it by 3.65, and that will tell us the partial pressure. 2.46 atmospheres is the partial pressure for helium. All right, moving down to 6 now. Calculate an R value. So we're setting up a ratio. So we will have the 2 R values that we know. We don't know the R value for KIPS, KSI, but we do know the R value for atmospheres. We do know that 1 KSI, I have it as a KIP here, sorry, we'll do it KSI. KSI is equal to 68.046. So the R value for atmospheres is 0.0821. So now all we got to do is just cross multiply. So 0.0821 divided by 68.046, and you get some very, very tiny number, 0.00121. All right, number 7. How many grams do you have? If an unknown gas at a pressure of 1.2 atmospheres, a volume today, and a temperature, how many grams do you have? So this is PV equals nRT. So P in this case is 1.2. V in this case, 0.877. N, we don't know. We don't know N because we're looking for the mass, so we don't know it based on the number of moles. Otherwise, it'd be a straightforward conversion. The R value, because the pressure is in atmospheres, we'll use 0.0821, and the temperature is 87, so we'll have to add 273 to that. Makes that 360. So we will solve for the N and then convert it into grams. So 1.2 times 0.877 divided by 0.0821 divided by 360 gives me number of moles is 0.0356. We multiply that by the weight of this compound. Carbon is 12, 5 of the fluorines, 5 times 19, plus another carbon, plus 1 iodine, 127. Gives me 246 is that mass, times 0.0356 gives me 8.76 grams. All right, question number 8. How much faster is this? So Graham's law is in play here. So the rate over the rate, the mass over the mass. Now, what are we going to do? The gases are SO2. I'm just going to put it first because that's what it lists first, N versus N2. So the mass of N2 over SO, no, I've got that reversed. SO2 needs to be on bottom. So you have to do the inverse. So what we will do is we will sum this up. Mass of N is 28 and the mass of SO2 is 64. So 28 divided by 64 is square root of 0.4375. Do the square root of that value and you get 0.661 slower. Or what we could do is we could inverse this one. And so we would say that I've got 64 over 28, square root of that, and that's where we get 1.5 times faster. So if your answer is 0.61, it asks for how much faster it is, not how much slower it is. So that'd be the only reason why it was not marked correct on your paper. All right. So that takes care of 7. Last question on the exam is drawing the pictures. We have 3 different versions here. We have 2 of them that are straight. We have 1 of them that curves. Boyle is the one that curves. Gay-Lussac and Charles. Charles is volume and temperature. Gay-Lussac is pressure and temperature. And Boyle is pressure and volume. Okay. So that takes care of everything on the test. Thank you so much for paying attention. I will talk to you again soon. Hopefully you can communicate with me if I screwed up something on your grading. Talk to you soon.